Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105. This video is all about the summary of Chapter 6. So, the Chapter 6 is entitled as the Network Layer. So, the Network Layer or the OSI Layer 3 provides services to allow end devices to exchange data across the network. So, we use our end devices like the cell phones, laptop, desktop, and iPad. So, different gadgets. So, to exchange data over our network. So, for us to communicate to others or to give data to others. So the network layer uses for basic processes. So the first one is addressing end devices. So the addressing end devices must be configured with a unique IP address for identification on the network. So the end devices our end devices should have an unique IP address so that the network can identify it easily. So the next one is encapsulation. So the network layer encapsulates the protocol data unit or the PDU from transport layer into packets. So in this layer they will encapsulate the protocol data unit. So next one is the routing. So the network layer provides services to direct packets to a destination host on another network. The last one is decapsulation. So if we have the encapsulation, we have the decapsulation. So when the packet arrives at the network layer of the destination host, the host check the IP header or of the packet. If the destination IP address within the header matches its own IP address, the IP header is removed from the packet. So if the IP address match, that's the only thing that they will remove from the packet. Network layer protocol. So there are several network layer protocol, but here it only has two. They are the Internet Protocol version 4 or the IPv4 or the Internet Protocol service Internet Protocol version 6 or the IPv6. The first one is connectionless. So no connection within the destination is established before sending data packet. So the next one is best effort. So IP is inherently unreliable because packet delivery is not guaranteed. So it is not reliable because it is not yet guaranteed. So the next one is the media independent. So the media independent is the operation is independent of a medium. Example, copper, fiber optic, or the wireless carrying the data. The IP is connectionless, so it doesn't have any end-to-end connection is created. So created before the data is best effort is unreliable, so it is not yet guaranteed. IP media independent. So IP packets can travel over different media, so they are independent. They can travel alone in different media. IPv4 packet header. So this version contains of 4 bits binary value set 6.2.0.1.0.0 that identifies this is an IP version 4. So the identification of the IPv4 is the IP address of 0.1.0.0. Then differentiated services or diffserv. So formerly called the type of service field. So the DS field is an 8-bit field used to determine the priority of each packet. So that is their differences. So the IPv4 use the version 4 or the 4-bit. Time to live. So contains an 8-bit binary value that is used to limit the lifetime of the packet. So the next one is protocol. So field is used to identify the next level protocol. So this 8-bit binary value indicates the data payload type that packets is carrying. Limitations of the IPv4 or the Internet Protocol version 4. So IP address depletion. IPv4 has a limited number of unique public IPv4 addresses available. So internet routing table expansion. A routing table is used by routers to make best path determinations. So lack of end-to-end connectivity. Network address translation is a technology commonly implemented within IPv4. So the IPv4 lacks of the end-to-end connectivity. And now I will introduce to you the IPv6. So in the early 1990s, so the Internet Engineering Task Force has a issue on the IPv4. So a while ago, I talked to you about the limitations of the IPv4. So that is the issues of the IP of the Internet Engineering Task Force. So they began to look for the replacement for the IPv4, and then the IPv6 as born. So this one is the improvements of the IPv6 increase address space. So IPv6 addresses are based on 128-bit hierarchical addressing as opposed to IPv4 with 32 bits. So in compared to IPv4, it only has 32 bits. So in IPv6, they make it as the 128 bits. So it has a lot of differences. So improved packet handling. The IPv6 header has been simplified with fewer fields. So they make it simple than the IPv4 for them to easily use. So eliminate the need of NAT. So I said before that the NAT is needed for the IPv4. So in IPv6, they eliminate it. So with such a large number of IP not between a private and v4 public is not needed. So in IPv4, the NAT is not needed, or the NAT is not needed. Encapsulating the IPv4. So the major improvement of the IPv6 to IPv4 is that they simplified it, so for them to easily use. So now I will discuss to you about the IPv6, so packet header. I will discuss to you the IPv6 packet header. So let's start with the version. So the field contains a 4-bit binary version set to 0110 that identifies that is not a IP version 6 packet. So in IPv4, so the value is set is 0100. Here in IPv6, it is the 0110. So the traffic class, this 8-bit field is equivalent to IPv4 differentiated services field. Then the next one is flow label. This 20-bit field suggests that all packets with the same flow label receive the same type of handling routers. So with the same flow label receive the same type. The payload length. So this 16-bit field indicates the length of the data portion or the payload of the IPv6. So in IPv6, they have now the identification of the length of the data that they will carry. Next, header. So this 8-bit field is equivalent to IPv4 protocol field, indicates the data payload type that the packet is carrying. The hop limit. So hop limit. This 8-bit field replaces the IPv4 TTL. So they just replace the TTL of the IPv4 with the hop limit. Source IPv6 address. This 128-bit field identifies the IPv address of the sending host. So it identifies the address of the IPv6. Then destination IPv6 address. This 128-bit field identifies the IPv6 address of the receiving host. So it identifies the sending host at the same time they identifying the receiving host. So that is, I think, the good for the IPv6. So they identify the receiving and the sending host. So host of forwarding decisions. So first is itself. A host can ping itself by sending a packet to special IPv4 addresses of 127.0.0.1. So it can ping itself. Then the local host. This is a host on the same local area network as the sending host. So local host. Then the remote host. This is a host on a remote network. The hosts do not share the same network address. So we use the remote if they will if they do not share the same network address. The default gateway. So we use the default gateway for the devices and the router or a switch to have a connection to each other. So it's like we set the IP address on the router. Then on PC, if we configure that, we will use the default gateway, the IP address that we put in the router or in a switch. In this video, I will say that the network is we use this to have a connection between the internet and our and devices such as the cell phones, the laptop, and the desktop computer. So we use this to have a connection for us to use our and use our devices and to have a communication with the others that is not uh, sharing with the same network. So that's all for this video. Thank you for watching.